We're going to look at circles and inscribed angles. Inscribed angles are angles that are formed inside the circle that have their vertex on the circle and the endpoints of the rays or segments that would form the angle on other parts of the circle. So as opposed to being just inside the circle, it's really an angle that has its vertex on the circle, and that's called an inscribed angle. So ABC here is an inscribed angle. Okay, so angle ABC is an inscribed angle here. All right, so every inscribed angle has an intercepted arc, an arc that kind of belongs to it. So the best way to find out what it is you trace the angle, and like Pac-Man, you swallow the arc. So if your angle can close or eat the arc, then that's your intercepted arc. All right, so if we want to know the measure of angle ABC, we called it angle X, then we have to look at its intercepted arc, which is measure of arc AC, and then we can take half of that, and that is your inscribed angle measure. So the measure of angle B, or ABC in this case, is going to be half of the measure of the intercepted arc AC. So measure of angle B equals 80 divided by 2, which equals 40 degrees. All right, and then when you are working with circles, you should always put your information on your circle because you never know if you're going to have to use it for another angle or other measurement that you can try to calculate in the circle. All right, next one, we want to find the measure of the arc AC. Well, that's this arc right here. So again, we're looking at this. There's no central angle that we can equate it to, but we do have an angle formed, and it's angle ABC or CBA. And the intercepted arc is what we can swallow if this angle were to close like a mouth. Okay, so it would eat this arc. So we really want to look at angle B to help us find the intercepted arc AC. So since we know that to find the measure of angle B, it would be half of the measure of arc AC. So since AC is the unknown, and we're going to do this purely algebraically right now, but common sense will kick in. Okay, so the measure of angle B equals half of whatever the arc is. So times 2, so the arc is 120. Okay, so the measure of arc AC is 120, and it's degrees because it's not a length. It has nothing to do with the circumference of the circle, but the sweep of the circle and how many degrees that happens at. All right, so you do your algebra, or you quickly calculate. If that's 60, that's 120. Put the 120 on here so you can see it, okay? And then make sure you put degrees on your answer. Okay, next problem. We want to find the measure of angle ABC. Now what's interesting about this angle is its vertex is on the circle. It's formed by chord AB and ray BC. Even though the angle is not inside the circle in its entirety, its vertex is on the circle, so therefore it follows the same rule as finding inscribed angles. So what you're looking at is if this were like Pac-Man, okay, an open mouth, and it closed, it swallows this arc right here. So this is the intercepted arc on this side from A to B. So it's the major arc ADB. So in this case, it's the same thing as an inscribed angle. So the measure angle ABC is equal to half of the intercepted arc, which is 210, which is the major arc ADB. So that's going to be 105 degrees. All right. All right, so if you want to write that in here, it's good right there. Now, what's interesting about the angle that you should note is that the angle is not all internal to the circle. This angle actually is partially in the circle and partially outside the circle. Tiny bit, but it is. All right. All right, now we got a little more complex looking problem here with a lot of chords, a diameter BC. Okay, we know that because it's going through circle O. We have some information that we need to put on here. Minor arc AB is 10 degrees. So we're going to write that out here. Minor arc BC is 20 degrees. So we're going to write that out here. We want to find arc, the measure of arc AE. All right, and it's not a major arc because it's going from here to here around. And we want to find angle C, and we want to find angle BEC, which is this angle right in here, right there, and angle D, which is here. Okay. All right, so I think the easiest one to find first is, I guess, let's look at it. We have, yeah, I would find arc AE, and the reason I would find minor arc AE is because your diameter is BE, this is 10 degrees here, so the rest has to be 170. All right, so that's, some of these are pretty easy to find and quick to find. Now I would write your information here because you're going to need it for other angles. I think the next I would find would be the measure of angle C, because the measure of angle C, okay, is AC, E, okay, and we want angle C. The intercepted arc is that 170 that you just found. So this is going to be half of 170, because that's an inscribed angle, which is going to give us 85 degrees. Okay. Now we're looking at measure of angle BEC. Okay. I'm going to highlight that in blue. All right. So BEC, from here to here, and I always trace these angles because then it's easy to find. And the intercepted arc is here, which is measure of arc BC, which is 20. So the measure of angle BEC is going to be half of the measure of the arc BC. So that's going to be half of 20, so 10. So this is 10 degrees. And I would put that right in there because you never know if you're going to need it. And we want the angle, a measure of angle D. All right, so let's look at angle D now. I'm going to trace A to D to E here. So that's angle D in here. And its intercepted arc, if I swing it around, is the 170. So this is going to be half of 170, which equals 85. All right, so you will find that sometimes some angles share the same intercepted arc, and you just have to trace the angle, swallow the arc, and you'll be able to calculate that. Okay. All right, next and last set of problems we have to work on. We have a quadrilateral inscribed inside the circle. Okay, so the circle is circumscribed about the quadrilateral. We have minor arc AD is 100. Minor arc DC is 60, and minor arc measure of BC or CB is 120. We want the angle measures. All right, let's see if we got enough information to find angle A. So I'm going to trace angle A, and the arc is this, which comprises of 60 and 120. So 60 plus 120 is 180. And so the measure of angle A is going to be half of the intercepted arc of 180, which is 90 degrees. So I'm going to put 90 here, or you can put a little right angle box there. Next, we want to find the measure of angle B. All right, so I'm going to trace that angle B, which is here, and its intercepted arc is 160, because it's 160. So this is going to be half of 160, which is going to give us 80 degrees. So I'm going to put a little 80 degrees in there. Now we want to find the measure of angle C. I'll do that one in green, and as you can see, it starts to get messy when you're writing all over it. But angle C, I'm going to trace B, C, and if I swallow up the arc, it goes all the way to here. So really, I need to know what the measure of angle AB is. So a little legwork over here. We have 120 plus 100 plus 60 degrees. Okay, and that's going to give us 220, 280. All right, so 280. And so what we're going to do is we're going to take 360 and we're going to subtract 280 degrees. And when we do that, we're going to get 80 degrees. So we know that this minor arc AB is 80 degrees. All right, so now we can work on angle C. So from B to C, swallow the arc. That's 100 plus 80. Okay, that whole arc is 100 plus the 80. So it's going to be half of 180 again, which equals 90. Okay. All right, next we want to find the measure of angle D. All right, the measure of angle D, I will trace again. A to D to C, so here's my angle, which means this whole arc here, from C all the way to B to A, so 120 and 80, which gives us 200. So it's half of 200, which equals 100 degrees. All right, so our angle D is 100, and our angle C is 90. And remember quadrilaterals, 90 and 90 is 180, plus another 100 is 280, plus another 80 is 360. So you can check yourself also. All right, last problem, a little more complex looking. Okay, I'm going to bring it up here for a little simplicity to see. Okay, we know that minor arc AB is 100 degrees right here. And we want to find X, which is this angle. And remember, it's a little bit in the circle, a little bit out, because it's formed by a chord and a ray. Okay, and it is not a diameter, that chord. Okay, so notice that. The diameter is BD. And we want to find this angle that's exterior to the circle, which is Y. And we want to find this arc AD, which is denoted by the letter Z. Right? Now, here we go. I think the easiest one to find, let's see what we got here. All right, so I think I'd find X first, because this is the chord. This is my angle here, all right, that forms this angle, all right, these two pieces. And when you were to take this angle, and this is its intercepted arc of 100, so X is going to be half of 100, okay, which is going to give us 50 degrees. So I'm going to write a little 50 here. That's my angle X. Okay. There's a few ways in which you can find angle Y. There's actually quite a few ways you can do angle Y. So that's really up to you how you see it. Let's see what we got here. I think what I would do now is find the measure of angle Z, because if this is a 100-degree arc and this is what I want to find, and we know that BD is my diameter, then this 100 and this piece here has to be 100. It has to be 180 in total. So this would have to be 80 degrees. So that's angle Z. Okay. There are a few ways in which you can find angle X. Angle Y. Angle Y. All right. One of them is you can find the rest of this arc here. So since this is a diameter, this would be 180 all together right here from B to D. Now, we haven't learned yet really about the exterior angles to a circle, but the rule is that the intercepted arcs get subtracted and divided by 2. But without knowing that, there's another way we can do this. We have a tangent here, and we have a tangent here. And we know that they're equal, because points of tangency that form an angle outside the circle are equal. Those parts, those segments are equal. All right, so that makes this BEA an isosceles triangle. Okay, well, if this angle is 50, then this angle is 50. So it's a total of 180 degrees in your triangle. 50 plus 50 is 100. And so 180 minus the 100 gives us 80, and that would equal angle Y. Okay, so angle Y is 80 degrees also. So there's a few ways you can go about finding these. Next lesson, we're going to learn another rule for this when we don't have other information to help. All right, and that is how you find the measures of inscribed angles and angles that are formed by chords and tangents, but the vertex is on the circle.